This is starting 1.6 for us, and we're just interpreting graphs. Although so much goes into being able to read graphs, so that I feel like this is really, really important. So just so we're clear, as we're looking at f of x and g of x, and the way this is written, each one of these is representing the y value. So in order to kind of answer this, what we're looking at are all of the y values for a certain graph when we're comparing them. So as we're looking at where f of x is equal to g of x, it's basically saying that we want the points of intersection of the graphs. But pretty much what we're saying is that each y value is equal to the other y value. So what it's asking for you to give is the x values of those points of intersection. And it's kind of the same thing when we talk about where f of x is greater than g of x. And you can kind of see what I'm talking about later down here is we're always giving the x values, but these are each curves. So in order for f of x to be greater than g of x, and we're talking about y values are going from the bottom to the top. We want the graph of f must be above. So the curve of f must be above the curve of g. And all I'm just saying there, and it might make more sense when I actually get to this example, I think f is the dashed line again, that we're looking at this portion because the dashed line is above the solid line. And again, make sure you give the x values for this. I think this will make a little bit more sense once I give you an example. And same thing with this one, it's just flipped. Now I'm not going to write g must be above f, I'm going to write f must be below g. Again, we're giving the y values. That's what this is. The y values are smaller than the y values. And y is up and down, or down to up. So it makes sense once you get practice with this. Now before moving on, I think it's important to point out that we can only compare where both graphs are defined. So as we look at f and g, these are the same. Maybe they're, I don't know. All three of these are the same. I think I've seen them pop up more than once. That we can only compare the graphs where the function is defined. So you can see that g is defined at -5, but f is not. The first time f is defined is once you get to -4, and we use a parenthesis to not include because it's an open circle there. But all of the other points between those are defined until we get to 7. But we can compare them at 7 because they're both defined there. Yeah, so as we get these, we're again identifying all the x values. Where f of x is equal to g of x, we're looking for points of intersection. So clearly at x equals -2, I think it's clear. Just give me the x value. They don't intersect again until we get right here. And again, I want the x values. When we're comparing functions like this, we want to give the x values. I believe that's 5. I'll go back to blue since I already did this. So now that we're looking where f, the dashed function, is above g, I already pointed this out earlier. But again, we cannot include -4 because it's an open circle here. Can't really tell now. And so my question to you is, do we want to include -2? That answer is no, because it's only greater than. Well, at -2, they're equal to. So if you wanted to change the problem, you could put an equal bar here and then change this to a bracket. But that is not how the question is asked. Is that the only place where the dashed line is above the solid line? No, because once we get right here, just to the right of 5, so union 5, the dashed line is above all the way till 7. Now should I include 7? Yes, I should. Okay, so moving forward to be f of x is less than g of x. I'll just switch colors one more time. Again, we can't really talk about from -5 to -4 because f is undefined there. So we can't definitively say. So the piece that we're looking for is this interval. It's below, it's below, it's below. I know this is really goofy how I'm writing it. But f is below the g. The dashed is below the solid. So you can just say from -2, not including -2 until you get to 5, not including 5, because they equal. And you can make them, if the problem said or equal to, then you could have 2 brackets there. We've asked this question before, really getting you to understand, should your intervals have closed with brackets or open with parentheses? Again, just like your previous videos, we have a big depends here. It depends if there's the less than or equal to, greater than. I feel like I'm writing the same exact thing I did before. It also depends if they're both defined. Are both functions defined? Things like that. So I have examples up here that have parentheses. I have an example that has a bracket, all parentheses, things like that. And since all of these functions are the same, let's just practice stating the domain and range. Now remember, we read the domain left to right. The domain is the x values. And so f is the dashed line. So the first time that x is defined is at -4. And it is no longer defined once we get to 7. So -4 with a parenthesis to 7. And let's stick with a range with f. So the lowest that the dashed line is defined is at -2, the y value. And I want a bracket there because it is a defined value. Got a closed dot there. And we stop drawing that once we get to this y value at 6. And again, I want a bracket because it is a closed dot there. We want to include that y value. And then same thing with g, but g is a solid line. Left to right for the domain, it looks like -5 with a closed bracket because it's a filled in circle till 7. So let me write that down. You can definitely see the spiraling. We keep going back and reteaching the same thing from lesson to lesson. So I hope if you were unfamiliar with domain and range, you're getting better before we take this quiz. And then the range of g is from the bottom, so the lowest g value looks like it goes down to -4, and the highest g value up here goes to +4 with no breaks in between. And they're both filled in circles. So they're both brackets. I think we're good saying that. So here's a very familiar function. You've seen this before. Again, f is represented as the dashed. G is a solid. I'm notorious for making mistakes, like mixing those two things up. So if you catch a mistake, just let me know. And we can also answer questions with only looking at one thing at a time. Now remember, this is the y value, so this is the same thing as saying y equals 0, which is just the x-axis. So we're looking at where the dashed line is f hits this value. It looks like x equals 1, but please don't forget, because sometimes I do, that it looks like this arrowhead going infinitely that way, I think I moved my screen a little bit, is going to hit at y equals 0 one more time at 13, 14, 15. And don't forget, I think this is the same equation as before, that you could create a equation of that line, like y equals up 1 over 2x. It looks like that y-intercept would have been negative 7.5. So if you set this equal to 0, and add 7.5 over, and then multiply by 2, you would have gotten 15. So make sure you extend the arrow out if it's on there. Looking at the next one, g of x equals 0. really it's the same type of equation, like y equals 0, except now we're looking at where the solid line hits. I think it's pretty clear that it's negative 4.5 there. Nothing to the left of this, but it crosses again at x equals 6. And then one more time, I'm going to just assume that that's 10.5. We could verify. We could work it out. So negative 4.5, 6, and 10.5. So now when we go, this is the new stuff, where the x values, where they cross each other. So they definitely cross right here. Let's see, the next time they cross, looks like it's definitely at x equals 9. The g function stops, so we don't have to imagine that going on again. But I do want to point out that you can get the exact answer of this if you set up linear equations. Like this looks like it's the slope negative 3. So I'm looking at that dashed line, y equals negative 3x plus 3. And then this curve looks like it's up 2 over 3, 2/3 x plus 4. And then you can do some arithmetic to figure out where they're equal to each other. I'll just do my arithmetic down here. Is equal to 2/3 x plus 4. I don't know how strong your background knowledge is in this. I know some students hate fractions, so they might multiply everything by 3 first. So that's all I'm doing right now. Multiplying this by 3 cancels the denominator. That's 4 times 3 is 12. So now I can subtract 2x over here. I can subtract 9 over there. And so I would get x equals negative 3/11, which is certainly better than just guessing. But don't forget about this x value either. And I really like that I did this because now I can go back to this value. If you just estimate this value, I'm not going to freak out about that. But now I can answer these other questions in a little bit more detail, because now when I'm asked where f of x is below g of x, where the dashed line is below the solid line, now I definitely get a good value. You know, that negative 3/11 was the first time that the dashed line was below the solid line, and it keeps being below until I get to 9. Because I don't want to include 9, I have to write it in interval notation this way. And then from 9, now be careful, because we can only say it's below for as long as both functions are defined. So they stop being defined at 11. Even though f goes on forever, g stops. So we have to stop at 11, and we're going to put a bracket there because they're both defined there. So just flipping it, for f of x being above g of x, the dashed line is above. Well, the dashed line is above from the beginning, but the first time that they're both defined is at negative 9. So above from negative 9 until we get to that negative 3/11 that I found. Hopefully all of my arithmetic was correct. And then after that, the dashed line is never above again. They're equal again, but not above. And then we've seen this problem before, being above the x-axis. So where's the dashed or f of x above the x-axis? Again, from the very beginning, so that negative 9 until we get to 1. Negative 9 to 1. And then, and it'd probably be faster if I just went back to that value instead of going back up from 15 to infinitely beyond. Now I'm going to stop the video because I don't have enough time to do these 3. So I will come back and get these 3 answers for you.